Hey guys, today is day 3. We're dealing with contingency tables. If you can believe it, then we just have Venn diagrams, review, and a test, and we're done with the semester. So let's get to it. We've got some old stuff first. So counting principle, it looks like probability and geometric probability. So the malls are opening soon. You're going to buy a new outfit. At the store you have 5 pairs of pants and 3 shirts and 2 pairs of shoes. How many outfits? That's counting principle. If you're picking one of each, it's 5 times 3 times 2, which would be 30 outfits possible, assuming that they all match. Okay, there's a bag. It has 3 white, 5 green, and 8 red marbles. What's the probability that you pull out a white marble? Well, our sample space is all the marbles total, so 16 marbles. So that goes on the bottom of our probability. There are there's 3 white marbles, so we get 3 out of 16. The probability that your marble is not red, again, sample space is still the same. Not red would be white or green, which is 3 plus 5, which is 8 out of 16. I would accept that answer. I would also accept half. I would also take 0.5. I would also take 50%. All of those answers are correct. Okay, I'm glad this geometric probability came up on the homework. A lot of you are not finding the shaded region. The shaded region would be the area of the rectangle minus the area of the circle minus the area of the triangle. All over the total sample space would be the area of the rectangle. So let's find those pieces. The area of the rectangle is going to be 30 times 16, which would be 480. The area of the circle is pi r squared. The radius is 4, so that would be 16 pi. And the area of the triangle is 1/2 the base times the height. It looks like the base is 4. The base is 8 and the height is 4, which would give you 16. So the area of the shaded is going to be the area of the rectangle, 480, minus the area of the circle, 16 pi, minus the area of the triangle, 16, all over 480. Now, if you want to clean that up just a little bit, that would be 464. Yeah, minus 16 pi. I just subtracted that 16 over 480. Unless you wanted to put it in your calculator, that's as exact as you're going to get. In your calculator as a decimal, that would be 464 minus 16 pi. Hit enter at the end of that. Divided by 480, you get 0.86 or 86%. Depending on how the author asked it, all of those answers are acceptable. Here's our new objective for today, is to understand what a contingency table is. So as you can see at that table, it's like it's a survey. So we've got male and female responses of if the person is right-handed or left-handed. I can see that in this bottom corner, I have 87 right-handed and 13 left-handed, which is a total of 100 people. I can see that 52 said they were male and 48 said they were female, which also adds up to 100. So 100 people were in the survey. The number of male, I can see right here. Let me grab a highlighter. The number of male, it looks like, is 52. And the number of female, they should add up to 100, would be 48. And then total left-handed would be 13. And the total number of right-handed is, it looks like there were more right-handed, 87. Okay, so this, now on the next slide, we're going to see some probability. What is the probability that a person polled was left-handed? Well, a person polled, sample space is 100. Out of those 100 people, it looks like 13 out of 100 were left-handed. There's my number right there, 13 total people. What is the probability that a person polled was female? Well, again, 100 people were polled. female, 48. You don't have to reduce, you can leave it just like that. What is the probability that a person polled is a right-handed male? Well, that's very specific. Right-handed male, let's find that in the table. Right-handed male, right here. Looks like there's 43, but it said a person polled, so that's, again, out of 100, 43 were right-handed, and they were male. So, more questions with contingency tables. This looks like maybe it was a poll where you had to check two boxes. One, female or male, and then two, highest level of education. So what's the probability of randomly chosen female is at most a high school graduate. Okay, so out of everyone chosen, 3172, how many are, I don't love the way that this is worded. I didn't mean to underline that. I wish it said is chosen is female and at most a high school graduate. So that would be these two under female. So out of the 3,172, let's add those up, 265 people were female and at most a high school graduate. Okay, same thing. What's the probability of randomly chosen person with some college is male? So it has some college and is male. I prefer that wording, but let's see, male and some college. Let's find that. So male and some college. It looks like it's 374 participants. Check two boxes, male and some college. Okay. So I just did this slide and I erased it. You could actually interpret this a couple of different ways. So first we're going to tackle this word given. So this is an R3. When you see this word given, it's going to change your sample space. So it says given that you're talking with a male. So that means that I'm only speaking with the 1,570 participants who are male. So that is going to be the bottom of my fraction. What's the probability that he has at most a bachelor's degree? So I'm going to interpret that as he has a bachelor's degree and not a graduate degree. So we're going to say that that's 463 over the total 1,570. Okay, let's try it again. I see that magic word given. Given changes your sample space. Given that you are talking with someone who has at most a bachelor's degree. Well, there are 1,002 people that have a bachelor's degree. What's the probability that they are male? That 463 still rings true. 463 people in this group out of the total group of bachelor's degree are male. So all that given business, that's called conditional probability. It's the probability that one event happens, I'm reading right here, given that another event has already known to have happened. So this is conditional probability to say, given that they are male, what's the probability that this has happened? Or given that they have a master's degree, what's the probability that they're female? That is conditional probability. So here's our last contingency table, and we're looking at cookie preferences. So we've got ages, and then, so again, it was like a survey. You checked a box for how old you were, and then you checked a box for your cookie preference. You could only pick one. So we have a total of 8,000 people that participated in this survey. What's the probability that a randomly chosen person in Minnesota favors chocolate chip cookies? Well, that's out of the total. Out of 8,000 people, doesn't matter how old they are, how many like chocolate chip cookies? 3,602 people out of the 8,000 like like chocolate chip cookies. Okay, given, there's that magic word, let's highlight. Given that you are talking with a person who's 70 years and older, okay? So 70 years and older, that's this demographic right here. That's your new sample space, okay? What is the probability that they favor peanut butter cookies? So out of that group, the 70 and older group, peanut butter cookies would be this one right here. Out of just that demographic, 70 and older, 136 people out of the 1,000 preferred peanut butter cookies. Okay, here's another given. Given, you are talking with a person favoring oatmeal raisin. Okay, let me make some, there we go. Okay, so we're favoring oatmeal raisin. So this group right here, 1, 8, 2, 0. All of those people favored oatmeal raisin. What's the probability that they are less than 10 years old? Under 10? 2. Apparently oatmeal raisin isn't fun for people under 2. Okay, last one. Given that you are talking with a person 50 years or older, so find the demographic 50 years or older. I think we're going to have to add some up because we've got 50 to 59, 60 to 69, 70. So we've got 3,000 people that are 50 years or older. What is the probability that they favor sugar cookies? Again, we're going to have to add. So let me erase these. Out of those, who likes sugar cookies? So, oh, I see frosted sugar cookies. So 6, 4, and 1. So that's a total of 11 people out of that demographic preferred sugar cookies. So that's it. What's the probability that my entire class will do the discussion board post for attendance? We'll get pretty close. And my entire class will complete the Schoology quiz due next lesson. Go ahead and give the Schoology quiz a try. Please find me on Google Meets if you have any questions. You can also feel free, if you made a mistake and you don't want to redo the whole Schoology quiz, you can find me on Google Meets and we can fix it on the spot. It's a little bit faster and I'd love to hear from you.